Good day, everyone. Welcome to the Certified Math Majors channel. Now, today I'm going to teach you a shorter way on how to find the derivative of functions containing natural logarithms. Now, for those who are taking up calculus, perhaps you already know the formula for the derivative of the natural logarithm of x, or the ln x. But for those who wants to know about the way of how it was derived, then you can subscribe to Gina's mathematics class. She has a video that exquisitely shows how to derive the formula for the natural logarithm functions. So, going back, the formula that we're going to use in order to find the derivatives of natural logarithm functions, the easier way is the derivative of the argument or its inner function all over the argument. Now, when we talk about the argument, it is the function after the ln notation. So, as you all know, that whenever we have a natural logarithm, it's always written as ln and then something else. And that expression or number written after the ln is always the argument, because without the argument, ln alone is meaningless, because ln is just a notation. It is instructive of what we are going to do with a certain expression or a certain number. So whatever is written after the ln, that is the argument. And then when you talk about inner function, there is an inner function if the argument has a function containing arguments that are not readily differentiable, or functions with a group operator. Now, let's take, for example, these three here. The first one, you have ln of sine 2x. After the ln, you can see sine 2x, so that means this is now the argument of ln. But this is not readily differentiable because we don't have the formula for sine 2x. What we have is just the formula for sine x, which means that we need to use the chain rule in order to find the derivative of sine 2x. Another one is ln of 5x minus 3 squared. Notice that 5x minus 3 is raised to the power of 2. That means the square here is a group operator because the 5x minus 3 is taken as a group. And similarly, the third example, you have cube root of 2x cubed minus 3x. The differential operator, or the group operator, is the cube root because you're taking the third root of the group 2x cubed minus 3x. So let's use this formula here to some examples. First one, you have y is equals to ln of 3x plus 2. So to get the derivative, you have y prime equals derivative of the argument. Argument is 3x plus 2. Derivative of 3x plus 2 is just 3. All over the argument is 3x plus 2. And this is our answer. No need the chain rule. Next, number 2. You have y is equals to ln of the square root of x squared plus 1. So first, we write the square root as x squared plus 1 raised to the power of 1/2. Next, use the formula for logarithms. Change this, or put this before the ln. So 1/2 ln of x squared plus 1. And then, you now have y prime, this is 1/2, times derivative of the argument. Argument is x squared plus 1, derivative is 2x, all over the argument of ln is x squared plus 1. So cancel this one out. You now have y prime is now equal to x all over the square root of x squared plus 1. Next, third example, y is equals to ln of ln x. So you have y prime equals argument of ln is ln x. So derivative of the argument is 1 over x. All over the argument is ln x. We simplify this. This becomes 1 over x ln x. Lastly, we have the fourth one. That's y is equals to ln of x plus e to the x. So y prime is just equals to the derivative of the argument. Argument is x plus e to the x, so that's 1 plus e to the x as the derivative all over the entire argument, which is x plus e to the x, and this is now your answer. So in those four examples, we were able to avoid the chain rule. And that's how you're going to find or get the derivatives of natural logarithmic functions the shorter way. So that's all for this video. Thank you so much. Enjoy learning.